Warm welcome also from my side. Let's start right away with the lessons learned from the application of the Humus key, which I used for my master thesis. My master thesis has the title Morphofunctional Classification of Humus Forms using the TerrHum app. And we want to look for correlations of morphofunctional indicators and standardized laboratory analysis parameters. Our field survey comprised 30 foresight plots. Foresight is the forest site classification of Styria in Austria. And we stratified our plots by siliceous and calcareous substrate, by climate, and by vegetation. In the graph, we see the vertical distribution of our stratified plots and the climate gradient. On the plot level, we selected 3 subplots, so-called microsites, and per each microsite, I describe one humus profile and classified the humus form with the TerrHum key. And furthermore, we sampled qualitatively each organic layer and the upper 5 centimeter of the mineral soil with a core sampler. With our laboratory measurements, we are almost done. We measured fresh and dry weights for bulk density, pH values, soil organic biomass, soil microbial biomass, and heterotrophic respiration, inclusively temperature and moisture response. So, some first rough results. The figures show us the depth distribution of the ratio of microbial carbon to total organic carbon within each humus system. We can see there is a gradient, and surprisingly, Moder and Amphi is quite similar. Generally, this ratio CMIC to CR is a potential indicator for microbial carbon turnover efficiency, and on which I will look at in more detail in the elaboration of my thesis. So let's head on over to my personal lessons learned from the application of the Humus key. So the most challenging issue was the separation of the organic layer to the organomineral soil, so between the OH horizon and the A horizon. And as I already mentioned, the organic topsoil layers were sampled qualitatively, layer by layer. And when the soil showed more mineral characteristics, we stopped collecting the OH horizon and took the core sampler to sample the upper 5 centimeters of the organomineral, or often also mineral soil. And even from this homogenized 5 centimeter samples, we had 24 of 90 samples with a higher carbon content than 20%. And this 20% is the official separation value between the OH horizon and the A horizon. Oh yeah, only afterwards I came across this graph in the Humusica articles. It shows the ratio between humic components and mineral components. And yeah, the awareness that the OH layer can contain up to 50% of mineral components is definitely higher as we assumed in the field. And also the information that mineral grains included in animal droppings and in these microbeds, that these are considered as humic components, would have let us separate probably in a different way. So I would suggest to add this figure, this helpful figure, to the app. The app included also a classification key. It was not that useful for me. The idea is that by answering yes and no question to classify a humus form, but due to the fact that it was often not so easy to answer with yes or no, I switched very quickly to the dichotomous tree key and the key in the Humusica article number 5, which I always carried with me in this folder, as you see. And yeah, and also all the general tables, figures, and great illustrated reference profiles were extremely helpful to come to a decision. Um, but as helpful as they were at all, this extra information, as confusing they were at the very beginning. So a better structure could be taken into consideration. Furthermore, I really liked the 2 extra Humus systems in the key, especially Amphi occurred quite often and was mainly very clear and easy to classify. And last and probably biggest lesson learned is the awareness of the variety of humus forms and the better understanding of morphofunctional characteristics, and also to detect the structures and traces of the dominant actors of biodegradation. And some of them we will see in the following slide. Thank you for listening.
Thank you very much, Anna.